Hi children, how to go about with this question of integration miscellaneous exercise 31, 0 to pi by 2 sine 2x into tan inverse of sin x dx. I feel like putting sin x as t. If you put sin x as t, I need a cos x dx will be derivative, but I don't have a cos x directly. But you should remember sin 2x can be written as 2 sin x cos x. That way I will rewrite. So this will be written as 0 to pi by 2, 2 sin x cos x tan inverse sin x dx. Now I will put sin x equal to t. So derivative is cos x dx equal to dt. Now this will become integral 2 sin x, I will put 2t, cos x dx will become dt, that I will write afterwards, tan inverse t dt. Now I will do integration by parts. Integration by parts, when I do integral, you know I late who should be first at inverse function. So I will write tan inverse t into t dt. Now let us start. So 2 into, what is integration by parts? First function into integral of second function minus integral of derivative of first function into integral of second function. So first function as it is into integration of second, t integration is t square by 2 minus integral of derivative of tan inverse t is 1 by 1 plus t square. Again integration of second function is t square by 2 dt. We have to integrate this further. So 2 into tan inverse t square by 2 minus this 1 by 2 I will keep outside, integral, this will become t square by 1 plus t square. We will do a little adjustment here, both are of same degree. So what we can do is, we will put 1 plus t square and minus 1, adding and subtracting a 1. So I can separately write 1 plus t square by 1 plus t square is 1 minus 1 by 1 plus t square. I will separate it and write. So this will become 2 into bracket, 2 is for everything, for the whole the function. So 2 into t square by 2 tan inverse t minus 1 by 2 integral 1, this by this is 1 minus 1 by 1 plus t square dt. So this will become 2 into t square by 2 tan inverse t. I could have cancelled, multiply, if I multiply 2 inside, this 2 and this 2 cancel. So I don't want this 2 here. So I will write just t square by 2. Imagining you multiply this. Here also this 1 by 2 gone. So integral, this we can integrate. What? 1 integration is t minus 1 by 1 plus t square is tan inverse t. Okay. Now everything is over. Integration is over. So it is coming to this extent, t square into tan inverse t. If you want, you can write common factor and write. You can take a tan inverse t, common factor from this term and this term. This is t square tan inverse t with minus minus plus tan inverse t. So here what will come is t square will be here, minus minus tan inverse t gone means it will be plus 1 minus t, like this. Now we will put it back, otherwise we have to change the limit to, or you can change the limit. When sin x is t, if x is 0, t also will be 0. If x is 0, t is 0. If x is pi by 2, pi by 2 is the upper limit for x. If you put here pi by 2, that will become 1. That is little more easier. So this will become tan inverse 1 into 1 square plus 1 minus 1 minus, now when I apply 0, t is tan square 0 into t square, tan square 0 is 0, tan inverse 0 is 0, then this whole stuff will be 0, minus t is also 0, so this no need to write, this is 0 only. So this will become tan inverse 1 is pi by 4, 45 degree, this will become 2, so into 2 minus 1. So that finally will become pi by 2 minus 1. If you didn't get once again carefully watch, here sin x if you put as t, 2 sin x cos x is this. So cos x dx will become dt. This will be 2t tan inverse t. Wherever I have sin x, I put t. Cos x dx is dt. Then 2 you keep outside, tan inverse t into t. Integration by parts, first function integral of second minus integral of derivative of first function into integral of second. Then we need to make an adjustment. This you should make a note of this. You add 1 and subtract 1 so that you can convert this into what? 1 minus 1 by 1 plus t square. So 1 integration t, this is tan inverse t. Then you find the, when x is 0, sin 0, t is 0. When x is pi by 2, t will become 1. So you apply the limit. Carefully work out once, then you feel it's good. Okay.